presentation is the next lecturer is Dr. Sanjay Swami with the paper entitled Rift Valley Treatment of Hilly Terrains, Soil and Water Conservation. Dr. Sanjay?
Yes, Dr. Rina, I am here.
Okay.
Okay, thank you so much for inviting me. Honorable Chair, Co-Chair, respected delegates, dear participant, a very good afternoon to all of you. Really, it is proud privilege for me to be present and to be associated with this program. I appreciate the efforts of Dr. Harsat. I am also associated right from the, you can say, inception of this program. And I extend a very hearty thankfulness to providing me this opportunity to deliver a lecture in this important Summerfield School. So let me see that my topic is on this bridge to valley management. I am sharing my screen right now. I think my slides are visible.
Yes, are visible your slides.
So today I will discuss something regarding this ridge to valley treatment of hilly terrain so that we can ensure the soil and water conservation, particularly in the watershed areas. So friends, as you know that already we have overexploited our natural resources, and our population is increasing day by day. Right now, if we see the particularly scenario of my country, India, we have almost 1.39 billion peoples, and by 2050 it is expected to be 1.65 billion. That means that the population pressure is increasing, and this is almost increase is around 30% in the population, whereas right now we are producing almost 270 million tons of food grains right now, and by 2050 to feed this population we will need around 3,077,000,000 tons food grain. That means we have to produce almost 43% more food grain to feed this population. Likewise, right now we have almost 142 million hectare lands, and that will almost remain same by 2050. It is showing that we have lot of population pressure. We have to produce more to feed this growing population, but the resources, maybe land, maybe water, that is going to be almost same. So what is the solution? How we can manage all these things? You know that even we are facing the climate change. We are depleting the natural resources, and there are so many pressure from market also, and we have very vulnerable communities. So how we can address all those things? You see the land degradation. it is happening at the alarming pace. And almost over 1/3 of the global population is inhabited in this land degraded lands. 24% of the global land area, it is already affected with the degradation. And over 1.5 billion people, their lives on the degraded lands. Now we see, we, the human, we are the reason, and the human induced soil degradation, it has affected almost 1,960 million hectare area, particularly only the one factor, one agent, we. Now, if you see the different continent-wise, the degraded areas, the Asia, in different degrees, if we see, then Asia comes measure in light and moderate degree of land degradation, whereas the Africa, it comes under strong and extreme land degradation category. And others also, they have different category, different type of land degradation. Then coming to the different agent, different causes, how means this land is degraded, and you can see very easily that these water and these wind, these two are the major factors of causing this land degradation. Water is representing 55.7%. It means the majority of the land degradation is due to water agent, and followed by this wind. And there are some other factors, other causes like nutrient decline, salinization, compaction, pollution, waterlogging, acidification, and of course subsidence. Now, if you see different, you can say the particular causes, different factors, then you can see the overgrazing. Overgrazing followed by this deforestation and then agriculture. These are the, you can say, the factors which induce the soil degradation more. Now, coming to Indian scenario, you see that we have the 18% of world population, whereas we have only 2.4% of the total land area of the world. That means we have the much pressure on our land resources. Likewise, we have almost 29.3% degraded lands, degraded soils, and till now we have targeted to restore only 1.5% lands by 2030. Now you can imagine how much time it will take to make usable this degraded land resources. And of course, the situation is very alarming. The consequences is that the people, the villagers, they have to cover long distances to fetch the firewood. They are not getting firewood. Likewise, the children, they are malnourished. They are not getting proper nutrition because we are not producing the nutritive foods. And of course, there are many villages, particularly in Rajasthan and Madhya Pradesh, where in summers there is no drinking water. For a single drop, we are not having. And for that, some NGOs, the social organization, they are arranging some measures like some wherever this train facility is available, one train is going, or some tractor mounted tanker are available for this drinking water purpose. Likewise, we have the you can say the cattle population which are roaming here and there, and in during droughts, even the social organization or NGOs, they have to make camps for this type of cattle to feed them properly. Now, what may be the solution? So one of the important area is watershed development program, because it has the capacity, it has the potential to change this scenario. Now coming to the watershed. What is watershed? Actually, it is a geographical unit, geographical area that collects rainwater through different channels into a stream or just drain into a waterway or river. Actually, it is a socio-ecological unit. You can see here, this is one geographical unit, one watershed area. The water is coming from all these lines, and ultimately this water is reaching up to a common drain, common point. Okay, so this is just a watershed. Every land is having relationship with watershed. Every land is having a watershed area. That may be a small watershed, that may be a large watershed, and of course all the people living within this watershed area, they are part and parcel of this unit. For more, you can say more easy understanding, you can say that this when there is any rainfall event, this water is coming to the downwards, and different channels, different ways, it is coming like this, and just it is collecting in a common drain. And the top side, you can see that particularly the arrows, they are indicating that water from all those areas is coming to a common point, but water from the other side, that is going somewhere else. So that is separate watershed area. But this line where we have written this divide line, this is actually the ridge line of this watershed, and the water is coming all from ridge lines to the bottom line, to the valley. Now you can see here also that this line, it is the watershed line, or you can say the ridge line, and only this part of water, this is coming towards the this drainage channel, and the arrows which are marked with red color, the water is going somewhere else. So particularly this line is indicating the watershed line of a particular area, and the surrounding is some other watershed area. Now, depending on the size, we can just classify these watershed areas. If we have the areas from 1 to 100 hectare, then we may call it as mini watershed. If the area is from 100 to 1000 hectares, then it is micro watershed. Again, if the area is from 1000 to 10,000 hectares, we call it as milli watershed. And if the area is 10,000 to 50,000 hectares, it is the sub watershed. And if area is more than 50,000 hectares, we call is at macro watershed. Friends, because this watershed approach is a collective effort to conserve all the natural resources, all the, you can say, soil, water, biodiversity, we have to conserve, we have to regenerate. Okay, so that's why to develop a watershed, we have different type of approaches and different type of treatments. So first, you can say that to develop a watershed, we have three type of treatments. First is area treatment. We have in this slide, you can see we have different areas, different land use patterns. So first thing is area treatment. How scientifically we can treat all these areas to conserve the water, particularly which is flowing from upper side to the lower side, so that we can conserve every drop of water. And if we are managing the velocity of water, the flow of water, we can reduce the soil erosion also, and we can improve the productivity also. Then second thing is this drainage treatment. You see that some drainage lines are here, drainage line. The channels, they are collecting in drainage line, and if we can manage this drainage line with some measures, we can also slow down the velocity of water, the flow of water, by putting different type of engineering structures. So the second part is this drainage treatment. And the third important factor is in situ water conservation or moisture conservation measures. Friends, we have different type of in situ soil and water conservation measures like this strip coating, all those things I am going to build in the next slides. But there are three major parts that we have to treat our areas scientifically. We have to maintain, we have to develop this drainage line with the proper engineering structures, and of course we have to adopt proper soil and water conservation techniques in the fields. Now, just I have discussed that we have to regenerate natural resources which we have already exploited, and because of this, we are facing all these type of problems. Now, this regeneration of natural resources or resources, it is the utilization of equitable and sustainable manner. That's why uh, that that indicate that if we involve the communities, the local communities, and they utilize the resources in equitable and sustainable manner, then only we can ensure the regeneration of the resources. If still we continue by the this over exploiting of the resources, we are not regenerate, we can't regenerate the our resources. And for this, we have to build the capacity of the local communities, local institutions. We have to educate them what benefit they are going to get, what type of, you can say, the benefit shares they will get. Now, actually, it is a socio-technical, you can say, the unit where first thing is we have to means consider the local inhabitants, local community, and in every aspect, right from, you can say, the planning of this watershed development program, the organization, education, implementation, monitoring, then only we can able to implement all those things and maintain all those structures which we are going to put there in watershed area. And we have to motivate, we have to mobilize the local people for some, you can say, just like social taboos, we have to put social taboos, we have to just extract some labor, some down like things, so that the uh, local people they can contribute. And we have to put ban on grazing, ban on tree cutting like the social taboo. That I mean to say that if we are not fully involving the local community, we are not going to get this benefit of this watershed development program. Now, this ridge to valley treatment, friends, particularly if you see the watershed structure, I have already explained the ridge line. That is the, you can say, the uppermost line. Okay. Now, the the measure, you can say, emphasis is that we have to treat first the upper area, and for that we have to convince the local people, because this is the practical problem that the local people they are saying, first treat my field, start from my area. But we have to make them educate that in this approach we have to first treat the ridge line, and then we have to come to the bottom areas. So friends, to decentralize soil and water conservation treatments, we have to take all these measures. And by putting all this area treatment, this drainage line treatment, and this in situ practices, we can able to reduce the runoff velocity, and of course increase the time of concentration of fast flowing water. This is very important. See, if one rainfall event is there and the time of concentration is less, that means this time of concentration is just, you can say that the time which when this rainfall drop is falling, and when it is reaching to the common point, common drain, that time is time of concentration. So if that time of concentration is less, then it is very dangerous. But if the time of concentration of this fast flowing water is high, then we can manage something. Now we can see again that this is the second principle, that we have to scientifically execute all these programs. And again, as I have discussed earlier, that we have the three treatments. We have the area treatment plan, we have the drainage line treatment plan, and the in situ soil water conservation techniques. So this all these things we have to execute in a scientific manner so that we can draw the maximum benefits. Now the third thing is the treatment of contour line. Hence, the water harvested in treated area that remain at a uniform level. You know that how the leveling of the water is very important. And if we are not treating the areas on contour line, then we can't get the uniform moisture level throughout the soil layer, throughout the you can say the within the soil part. And if we are not getting the uniform soil moisture, we may have somewhere good vegetation, but at some other part we may not have vegetation at all. So the leveling or the contour lines help in land leveling over a period of time, and definitely we can have a good vegetative cover by treating the contour lines. Now you see that here this picture is I think of 1996. You can see this area, it is almost barren land, but in 2009, after treatment of this land, this area particular in watershed, we have good greenery here, and these are shown by these maps here. Here the red lines, red dots, that indicate the bare land, but here it has been reduced and the green area has improved. So friends, in nutshell, that's watershed planning. It is actually a land use planning. First, we have to plan. We have to plan what is the soil texture, what is the soil depth, how much soil is getting eroded, what is the land slope. All things we have to take in measures. Then, of course, we have to see the land capability classes. After a thorough study, we have to classify the land. Uh, in land suitability classification, we have only two classes, four classes of land capability that are suited for cultivation, and the rest four that are not suitable to the cultivation. After that, after looking at the capability classes, we have to plan for land use. That that must be, you can say, the beneficial for the local community. And then we have to go for the watershed treatment activities to means ensure the reduction of the this water velocity. Coming to the land use, according to this land capability, the class first, as I told, first four classes, they are suitable for cultivation. So first, within this S1, we have the class 1, and there we can have the intensive cropping systems. And in class second, we have the cropping systems, but still we have to manage, we have to put some conservation measures, okay, some conservation cropping systems. In class third, we have this restrictive cropping system. In class 4, we can go for agri-horticulture or agroforestry like crops. And this next S2, the lands which are not suitable for cultivation, there again we have four classes, and these comes into class 5th to class 8th. Class 5th, where we can go for this pasture or range crops, woodlands. Then in class 6th, again we have the afforestation, pasture, dryland, horticulture. In class 6, it can be used only for grazing, or you can say for wildlife culture. But the class 8s, we can use only for wildlife or some recreation purpose. That is the, you can say, the worst category into the land capability classification. So we have to classify our land, and accordingly we have to plan what type of crops or what type of land use plan we should adopt. Then again, this social unity and discipline, it is very important thing. As I told you, that if we can't educate, we can't explain that what type of benefit the local community they are going to get, and if they are not following the rules and regulation put by this Microset Watershed Agency, they are not disciplined, then we are not going to get any type of benefit from this program. For this, we have to catalyze, we have to create events for democratic process in the atmosphere and of relaxed tensions. We have to contact the community institutions and watershed barefoot technical expert to educate them. The some social disciplines, as I told earlier, that we can use the controlled grazing of animals. We have to be use of borewells for irrigation, and of course for community ownership, we have we have to extract these samdan like things, voluntary labor and community share in waterside investments, so that we can share the benefits in the same ratio which they have already contributed in terms of maybe the voluntary labor, or maybe in the form of investment of capital. Friends, again, we see that this soil, water, these are the natural resources, and it is a human right. That's why we have to ensure that every part, it may be this human, it may be livestock, maybe biodiversity, everything get their share in a proper ratio, so that we can develop the good, you can say, the watershed program. And the important thing that
2
if
minutes
we are
more,
putting
please.
different type of structure, we have to take care of all these structures. Otherwise, in long run, after some time, they are not properly functional. That therefore we need proper maintenance and
I think that Dr. Swami have some issue with the internet connection. Okay, it's online now. Dr. Swami, if you want to present us your conclusion to your presentation.
yes. Okay.
2 minutes more, please, Dr. Swami.
Okay. Okay, then just I have discussed that this in a watershed development program, we have very important this time of concentration. Already I have explained that this TC is the time taken by the raindrop fallen at the point of R to reach the outlet or the common drain area. And of course, I already told that the TC can create even flood situation if we are not managing this. Okay, so we have to be careful regarding this time of concentration. Then again coming to this area treatment, I told you that it is linked with the land use planning, land use system. Okay, like this in agroforestry, we can use different this continuous control trends. In crop cultivation, we can use terracing. In pasture cultivation, we can adopt this contour stone bund. In again afforestation, we can adopt this water absorption trends. Back. Then in crop cultivation again we can have water bunds, like this different type of you can say practices we can adopt in the area treatment category. Then again for this drainage line treatments, we have different structures like this stone gully plugs, then this LBS, Gabion structure, earthen nala, cemented nala, stepped CNB, different type of you can say the engineering structures we can put in different areas according to our need. So I am is first this area treatment, this continuous contour trenches that you can see here that how these contours we can prepare, we can excavate this excavation we can perform at the and this should be at 0.6 to 0.3 meter size, and we can keep the ties at 5 to 10 meter interval, and horse we can give at the end of the. Then this refilling of continuous contour trends, again, you can see that here depth of refill trends should be at the point of this 0.5 meter, and this refilling should be done in the period of 1 to 3 months before the onset of the monsoon. Okay. Then again, the next, you can say the things which we can adopt is staggered guard trenches. We can have a look of these staggered guard trenches here. Then this contour stone bund, just like the, you can say the different type of the stone bunds we can prepare on contour lines. Then contour stone farm bunds, again here we have the this practice is very old and skilled person is required. The simple stones we can put without cementing them, so that these water flows from the upper side can be checked. Then water absorption trends here, it saves the downstream treatment from the intense storm, and it should be strictly taken on contours. You can have a look of this water absorption trends here. Then contour bunds, again these contour bunds, or we can say field bunds or wastelands and arable lands to improve the soil moisture retention. This is the simple purpose, and in these areas we can promote the growth of grasses, trees, crops, particularly in the contourment areas. This is simply the participatory net planning, how this particular area which we have shown in the cadastral map. This is before the planning, and here we have make different type of structures, engineering structure, just put in the map, so that we can plan accordingly and we can put this engineering structure for maintaining of this drainage line treatment. And here we have the different type of engineering structure. That first is stone gully plug, that you can see that we have made in series of this many these stone gully plugs, and it should be taken once area treatment is completed. First we have to complete the area treatment, then we have to treat the drainage line. Okay, then this loose boulder structure, as the name indicate, the loose boulders, they are just gathered, this collected here, and the this is maintained from both the side. And in gabion structure, we have already the, you can say, the wire gauge, and that is filled with the stones and put in the drainage line.
Dr. Swami, please present us your conclusion.
Yeah, then again we have different type of earthen nalas, bund, check dams, and this is the picture of this earthen nalas. Here we have some, you can say, the joint this bunds. Then we have the example here in our area in Nagaland. We have a system of this water impounding that is known as Zaba system of cultivation. It is very unique to particularly this area. And here we have on the top of the hills we have the catchment. Then we have water harvesting pond. In the next slide you can see here that this is the catchment area, this natural forest area, and the water is coming. And before this the water storage pond, we have kept one siltation tank, so the silt will go in here in the siltation tank. Then the pure water is coming here. Then we have the cattle shed. When we are going to irrigate the crops, this water is coming from here. And in the lower areas we have made terraces, and here we are growing the paddy. Then I have a small video just to means for better understanding of the participant, because most of the students here are maybe graduate or postgraduate students. So just looking at this video, they can understand better.
I think, doctor, you have already consumed 12 minutes.
Only 5 minutes.
No, 5 minutes is very much. So people can see the watershed videos. There are a lot of videos on the YouTube.
Okay then.
We can also put your video links on the website.
Okay.
No problem.
Okay then.